In today's lesson, you'll learn about 3 different types of reasoning. The first is direct reasoning. We are to write an argument about this Euler diagram. From our lessons previously, we know that Euler diagrams represent conditional statements, where the inner part of the Euler diagram is the hypothesis of your conditional statement, and the outer part of your Euler diagram is the conclusion of your conditional statement. So our inner part, drives at 80 miles per hour, is our hypothesis. So if a person drives at 80 miles an hour, is the beginning part of our conditional statement. The conclusion is the then part of our conditional statement, which in this case is the outer part of the Euler diagram, which is breaking the law. So then they are breaking the law. We see that John is represented as an X on the inner part of our Euler diagram. So we know that John drives at 80 miles an hour. Therefore, since we know he drives at 80 miles an hour, and our conditional statement says that a person who drives at 80 miles an hour is breaking the law, we can conclude that John is breaking the law. In direct reasoning, if you're given a conditional statement first, then we need to make the Euler diagram and then our conclusion. Our conditional statement is, if an ROTC student wakes up at 5 a.m., then they will go running. So for our Euler diagram, the hypothesis of that statement will go inside. And our hypothesis here is an ROTC student wakes up at 5 a.m. And our conclusion, they will go running, is the outer part of our Euler diagram. So I'll put running here. Our next statement says, on Tuesday, Sally, who is an ROT student, wakes up at 5 a.m. So Sally is an example of an ROT student who wakes up at 5 a.m. So I'm going to place Sally here, where it says ROT students wake up at 5 a.m. Therefore, what can we conclude? Well, since she is a ROTC student and she's waking up at 5 a.m., therefore, we know that Sally goes running. For indirect reasoning, we still use Euler diagrams, and in this Euler diagram, we still have the same conditional statement. But we see a picture of John. John is on the outside of breaking the law. So since he's not on the inside of that circle of breaking the law, we know that John is not breaking the law. So we say John is not breaking the law. Therefore, since he's not on the circle, since he's not inside the circle of breaking the law, and inside that circle is drives at 80 miles an hour, we can conclude that John is not driving 80 miles an hour. For indirect reasoning, we will still be given a conditional statement and asked to draw an Euler diagram and to come up with a conclusion. In this example, we have the same conditional statement. If an ROTC student wakes up at 5 a.m., then they will go running. So I'll redraw that Euler diagram. And our conclusion is running. On Tuesday, Sally, who is an ROT student, does not go running. So if she does not go running, she is outside the square of running. So I'm going to put Sally out here. So if Sally's on the outside of the running square, then she can't be on the inside of the ROC student waking up at 5 a.m. So we can conclude, therefore, Sally does not wake up at 5 a.m. Our last reasoning is transitive reasoning, and it says to write an argument. And in this Euler diagram, we see that there are 1, 2, 3 rings. So it is a conditional statement. There are 1, 2 different conditional statements. Our first one, starting with the innermost circle, will be the hypothesis, driving at 80 miles an hour. So if a person drives at 80 miles per hour, then we look to our diagram to see what the conclusion of that's going to be. And we go to the next circle, which is speeding. Then we can say, then they are speeding. For our next conditional statement, we start off with the speeding as our hypothesis and the next outside circle being our conclusion. So if a person is speeding, then, and the next most circle is breaking the law. So then they are breaking the law. Therefore, for our conclusion, we can see that if a person drives at 80 miles an hour, then they are speeding. If a person is speeding, then they are breaking the law. So if we take our first hypothesis and connect it with our last conclusion, we get another conditional statement. If a person drives at 80 miles per hour, then going all the way down to my last conclusion, then they are breaking the law. So draw an Euler diagram. What can you conclude? Humans are mammals and mammals are animals. So we can say that we have 2 statements here. So we're going to need 3 rings. Our first one is humans are mammals. So I'm going to put humans here and mammals here. And we know that mammals are animals. So I'm going to put animals there. So what can we conclude? We can conclude that humans are animals. Transitive reasoning is similar to logical chains, where you would just say, if you're given A, you can conclude B, and if you're given B, you can conclude C. So therefore, if you have A, then you can conclude C. So for these three conditional statements, if it is cold, I can go ice skating. If it is March, then the wind is blowing. And if the wind is blowing, then it's cold. I just need to reorder it so that it makes sense. This statement would go first. This statement would go second. This statement would go last. And therefore, we can conclude, if it is March, then I can go skating.